Alright, so this one's a little, I think, probably the more difficult of these problems because I kind of threw a lot into one question. So this is number 8. So you have to indicate which graphs meet the following. It could be more than one, it could be one. So let's look at it. So it says a particle experiencing a constant negative acceleration. So remember, that means that acceleration is not changing that entire time, but it is negative. So we can look at our acceleration graphs and be like, okay, that doesn't work, that one's changing. This is at 0, so it's not negative, but this is in the negative section. So your graph is constantly negative here. So H would be a good response for this. However, it's not the only one. Because remember, if we are doing this, which we always will be, if we're talking about constant acceleration, that's going to affect the velocity graphs, or even possibly position. So if you have a velocity graph and you have a constant negative, if you have a negative slope, do I have any negative slopes on my velocity graphs? Well, this is not, wait. We have a negative slope here, right? We are speeding up, going backwards. We start out going positives, and then we start going backwards here. That means we must be decelerating so much we start going in the opposite direction. So D is also an answer. You can look at your X graphs. You'd want, remember, an unhappy face for negative acceleration. I see 0 and happy faces. This kind of does something, but not really. So your answers could be H or D. Alright, let me erase all this I wrote on here. So let's look at the second one. So it's asking what has constant negative velocity. So this means your velocity is not changing. So let's look at our velocity graphs. Are there any where they aren't changing? Alright, so we're changing here. Alright, we were positive, then we went negative, so our velocity did change. Here our velocity was 0, and then it went up to positive, so it's also changing here. This is constant, but it's in the positive section, so that also does not help us. Okay, then let's look at acceleration. So if we're accelerating, is our velocity going to be constant? No. So you can take out that. This has acceleration, so that means you're decelerating this whole time. It's not going to be constant velocity. Technically, this has our acceleration be 0, so I could work. It's not the best answer, though. So let's look at our position graphs. B has all this, well, we're obviously changing velocity here. We went from positive velocity to a negative velocity here, because remember, for these, if you find the slope of your position graph, that tells us velocity. So we're looking for a negative slope that doesn't change. Oh, hey. Remember, we're going downhill. That makes it a negative slope, and the negative slope stays the same the entire time. A is by far your best answer for this one. Okay, if you need more explanation, I will be here at 7:30 on Friday. So please come and get extra help from me. Next one, particle experiences a changing negative velocity. So we need a negative velocity that also is changing. So this is a constant velocity, doesn't work. This is a positive velocity, doesn't work. This is no acceleration, that means nothing's changing, not positive. This is a positive change. So maybe, but we don't know where it started, not a good answer. This means we are decelerating and going negative the whole time. This is actually a pretty, you could say H, but you're really not sure because you don't know how fast you were going. If you were going really positive and then you just hit the brakes, you may never get to a negative velocity, so you don't know. Your best bet is here because we have a negative velocity that is getting more and more negative as time passes. So that would be D. And erasing, hopefully I think I'm going to run out of colors here. But let's go with a particle that starts slow, then speeds up, and then slows back down. So we're going to want something that has a really tiny velocity, a really big velocity, and then a tiny velocity again. Little v, big V, tiny v. So is there anything where we have a big V, a small v, a big V, and then a little v? This is constant, no change. This is positive, but then it's negative, it's not what we want. And this starts small, goes big, but never goes small again. Neither of these work. Alright, same thing, this would be speeding. You would be speeding up and slowing down again. None of these show that you both speed up and slow down. So it means all we got is position graph, something that shows that we speed up and then we slow down. This is we are going backwards the whole time. So this one, alright, we want both a positive acceleration, speeding up, and a negative acceleration. So you can see right here, the first half, it's happy. Second half, it's unhappy, so that's a positive, negative acceleration. So it means it's sped up here, this part, and then it's slowed down, which is exactly what we are looking for. So B works. You could possibly really push this one, but there's not a nice curve here, so C is not a good answer for this. Clear up this again. Alright, I'm going to go back to red as a color. So particle goes forward and then backwards. So we need, this is a positive velocity and then a negative velocity. So forwards and backwards. So acceleration, it should be positive and then negative. Nope, there's none of those in the acceleration. We can then look at the velocity. We need a positive then a negative. This is a 0 to positive. This is all positive. We start positive and then we end up with a negative velocity. D would work. Alright, let's look at any of our position ones. So we go forward and then backward. This is a negative slope the whole time. We're going backwards the whole time. Okay? This one, even if we're really slow here and here, this whole time we are still, kind of going in a positive direction. So this does not work. Alright, so this one we're going in the positive direction, and then we are going back towards the origin, or in the negative direction. So C also works. So C and D are both good answers for this one. Your justify would essentially be my explanation to you for all of these. What's happening in the graph, and why does that exemplify whatever we're asking for? Hopefully this has been helpful. Make sure you try all of your practice problems tonight.